This video is for 8.3. So we are going to be working on algebraic expressions today. So we have been learning about numeric expressions with numbers. And so now we're going to start adding in the algebra piece. So we will be using variables. So that is a word you may have heard before, but we'll dig deeper into it. So we'll be using variables to write an algebraic expression to represent a problem. So if you have not already done the Spark Your Learning, go ahead and give that a try and then come back and see how I thought about it. So this problem tells us that Viola is helping to plant a rectangular community garden. A plant handbook states that one plant requires 8 square inches of soil. So this is a really important word here, is 8 square inches. When I first read this, I just thought that there were 8 inches it needed, but it's 8 square. So the ways we can make 8 as a square or a rectangle, we could make a square, an array that is 8 by 1. We could make one that is 2 by 4 or vice versa, 4 by 2. So that commutative property gives us either way. So it needs 8 inches of soil to grow. You can't just plant a plant every inch or it's not going to have enough resources for it to grow. So given the dimensions of the rectangular garden shown, so our garden is 84 inches by 24 inches, how many plants can be planted in the garden? So I know I'm going to use this 2 by 4 rectangle. So I know that I have this area here, 84 by 24. So I need to give it 4 inches this way and 2 inches this way. So I need to create a rectangle that is 4 by 2. And I'm going to see how many of those can fit inside of here. Now, I don't want to draw that. So I'm going to use some math here. So I need to take 84 and cut it into 4 pieces. So 84 divided by 4 goes in there, 2 and 1. So that means I can fit 21 rectangles going across. So I can do 21 this way. And then if I take 24 and divide it by 2 to see how many 2-inch rectangles I can fit up here, that goes in there 12 times. So I can fit 12 rectangles this way. So I'll have 12 going up, 21 going across. So now I need to find out the array of how many 21 by 12 makes. So we're going to go ahead and multiply those. We've got 2, 4, placeholder, 1, 2. So it looks like it can hold 252 plants. They each need 8 square inches, and 4 times 2 would make 8. So I want to talk about this one other way here. So let's go ahead and let me get rid of a little bit of this here. So we are going to just find the area. We're going to find out how many inches are inside of this garden. So we're going to find the area, which is length times width of a rectangle. So we're going to do 84 and we're going to divide it by 24 to see how many 1-inch squares fit inside of here. So 4 times 4 is 16, 32, 33. Placeholder, got 8 and 16. So I add these together. There's 11. 4 plus 6 is 10 and 2. So inside this garden, there are 2,116 inches squared. So there are 2,100. If I broke this up into 1-inch squares, there'd be 2,016. But remember, every plant needs 8 of those inches. So I'm going to take this total here and split it up into, see how many groups of 8 I can make. So it goes into 22 times, which is 16. There's 4 and 1 goes in there 5 times. and 40, one left over, bring down the 6 and 2 times. So either way I did it, I ended up with 252 plants that they can plant in this garden that will give each plant 8 inches of its own soil to grow in. So lots of ways to do the same problem. So if you're ready, let's go on and do task 1. So in algebraic expressions, we're going to go over lots of vocabulary to get us started here. So an algebraic expression is an expression, so it uses numbers and operations that also contains one or more variables. So we've been using numeric expressions. We're going to add in some variables here. So maybe we have 32n. So it still has numbers, it still has operations, this is divide, but now we're going to add in variables. I could add an x here and have 8 groups of x plus 6 more. So a variable is a letter or a symbol. So we'll be using letters now that we're in 6th grade. We are going to be using letters instead of putting like a box to say what goes in the box. We'll be using letters, and you can pick what letter you want unless it tells you to use a specific one. I usually try and pick something that matches with the problem. If I'm looking for how many dogs, I'll use D. If I'm looking for apples, I might use A. So a variable is a letter that is used to represent one or more unknown quantities. So when you have a number that you're not sure of, you don't know how many you have, that's when you replace it with a variable. So for example, let's look at this expression here, this algebraic expression. So if I have 32, let's say I have 32 apples, and I want to give the same number of apples to a group of people, but I don't know how many people I am giving them to. I'm not sure if 3 people are going to come get apples from me, or if 6 people are going to come give apples from me, or 8 people. So by just using this equation, I can replace n with different numbers to test out my equation to see, or my expression to see how many apples people would get. So if I had 3 people that came to get apples from me, I would do 32 divided by 3 to see how many apples everybody would get. But if I had 7 friends show up, I would do 32 divided by 7 to see how many apples everyone can get. So that variable is unknown, and we can replace it with different numbers to give us different answers there. So a constant is a number that does not change. So this 32 was constant. I had 32 apples. That was not changing. No matter how many people came, I still had 32 apples. So whether 1 or 32 people came, I had 32 apples I could give away. So it's constant. It does not change. So another word we need to talk about is a coefficient. So I kind of like to think of it as the co-captain here. The coefficient is the number that is multiplied by the variable in an algebraic expression. So sometimes we might have a number that is maybe just 6 plus x. It's just x with 6 more. We might take 6 away from x. We might do 6 divided by x, or even x divided by 6. When you multiply, though, you always put the constant first, and then you put the variable right next to it. So no symbol is needed, and we call that the coefficient. So this is telling me I want 6 groups of x here. So let's look at a few examples. So we have 2x plus 25 is an algebraic expression. It has numbers, variables, operations, no equal sign. So 2 is the coefficient. I want 2 groups of x. X is the variable, so we need 2 groups of an unknown number. Maybe we need 2 groups of 10, 2 groups of 100, 2 groups of 79. So this X can change depending on what happens in the situation. And then 75 is the constant. This number is not changing. So any of these numbers, the 6, when we add or subtract or divide, we call those constants. When we multiply, it's called a coefficient. So it is kind of the co-captain of this number. They go together there. So let's look at a problem and see if we can write some expressions for task 1. So task 1 tells us that a daycare center has 2 baskets of dolls. So 2 baskets, basket 1, basket 2. So I like to just draw what I'm reading as I go. So 2 baskets of dolls. One basket has 8 dolls, so I know there's 8 dolls in this basket. And the other basket has an unknown number of dolls. So I'm just going to put N for the number of dolls. So we are going to write a numerical expression. So numerical expression to represent the situation. So that means I can only use numbers. So we know we have 8. And we don't know this number here though, so we are unable to write a numerical expression. That doesn't mean we just say, oh, well, I can't do this. We can actually write an algebraic expression in order to represent this. So they chose to use the variable x. So we can see here is one basket. Here is the second. So we know there are 8 in the first basket. So they broke the first basket up into 8. And we don't know this one here. So they just represented it with an X. Now to see how many dolls there are all together, we would add those 8 plus X. Then once we know how many dolls are in this basket, we could plug it into our expression and complete the problem. So go ahead and complete task 1. So task 1 is here. So remember, these vocabulary words are here to help us. So we're going to pick a numerical expression. Remember, you can only use numbers in a numerical expression. And then because we can't actually make a numerical expression, we're going to make an algebraic expression instead. So go ahead and do task 1, and you're ready to do task 2. Come back to this video. So task 2 tells us that Kristen works at a supermarket. She wants to divide a box of apples equally among 3 displays. So we have one big box, and she wants to split it into 3 groups, or she wants to split it into thirds. That's the same thing. Splitting something into 3 groups or into thirds is the same. So it tells us that we're going to use F as our variable to represent the total number of apples. So we're going to complete the bar model to express the number of apples each display will have by matching the variable or expression with its appropriate place in the bar diagram. So right here, it tells us F is the total. So we want to take F and we want to drop it into one of these boxes. So look at our model and think, which one do you think represents the total? So this looks like it just is this box here. This one is just here and here, but I can see this one has the whole thing. So we want to put F here. These are our total apples. So now we need to think about, what are we doing to F? So it told us it wants to divide them into 3 groups. So here, this was the total. This is 3 times more than the total. So that would be, if we put 3F representing this box, that would mean that we have 3 times more apples than we actually even have. So that one is not making sense for this situation. But if I took at this whole thing, it's showing that I have a third of F. Here's a third of F, and here's a third of F. 1/3, 2/3, 3/3. 3 out of 3 is one whole piece. So all of the apples together is one box, and we cut the box into thirds. So I know it said that we were going to divide over here. So we were going to take the whole box and divide it by 3. We can also use the reciprocal of that. So the opposite of 3 is 1/3. The opposite of divide is to multiply. These are equivalent because they're opposites of each other. So taking F and dividing it by 3 would give us the answer, or taking F and cutting it into thirds and taking a third of that. So let's substitute a number in for F. So let's say we have 12 apples and we want a third of that. So 1/3 of 12. So 12 over 1. So 12 times 1 is 12. 1 times 3 is 3. 3 goes into 12 4 times. So if I had 12 apples and I put them in a display, there would be 4 apples in each display. So, or I could take 12 apples and divide it by 3. I would still get 4. So you can see these problems gave us the same information here. So we know each display has a third of F. So we can write our expression as 1/3 F. So now Kristen decides she wants to place an additional 12 apples in each display. So we know this is what it started with, and now she wants 12 more than what it originally had. So I want you to think about how can you use this expression and give 12 more to the current display. So go ahead and complete task 2. And then that is all of your lesson today. And then you can go ahead and do your check for understanding and homework today. If you have any questions, be sure to let me know and we can set up a time that we can meet together.